Hello, Lucas. Welcome, welcome. Hello, everybody. So now we have Lucas here. He's going to be talking about deterministic AI for prediction market resolution. Are you ready?
Of course, yeah.
Okay, well, stage is yours.
Amazing, thank you. So, thank you, thank you everybody for being here. Today I'll be talking about a couple of buzzwords. Obviously, in 15 minutes, I barely have enough time to discuss in depth what it means to do deterministic AI. But you should definitely walk away with, what are all the necessary elements required for deterministic AI to have clear as well, hey, can I do deterministic AI with commercial models? So all of that jazz, actually, you would have a much, much clearer idea. And that's actually the objective of this talk. And of course, then I will be discussing how it applies to prediction markets and how we want to completely reshape how oracles are made for resolution. So to get straight into the jargon, I don't know if you were victims of these markets. I was into one of them. Won't be able to say which one though, but what do all these markets have in common though? The Zelensky wears a suit to Trump inauguration, or Ukraine agrees to Trump mineral deal before April. All of them resolved in a way that people didn't expect, even though the rules said very clearly what was going to be, the instructions for that resolution. And what is the problem with that? Well, we come back to we use natural language for these things. And when natural language says, the word should may mean different things, right? And there is no perfect solution for this. However, there is something that takes away and removes 99% of all the problems. And that is exactly the paradigm shift of, just like in the blockchain in permissionlessness, or when everything is decentralized, you can query whatever service, you can query Uniswap at any point. Why can't we query the Oracle resolutions, right, at Polymarket at any point during the open trading phase, right? And that's exactly the paradigm shift that that must happen in the field, and that's exactly as well what we are developing at Kash, the company that I lead in prediction markets. And it gets down to, if you query the oracle of, hey, whatever service that is, right? Hey, Kash, what if Zelensky were to use this very exact suit, right? What you expect from the oracle is to tell you the exact same thing that will, the exact same outcome that will resolve upon resolution, right? You don't want the oracle to say, actually, that's a suit, if you give an image of a suit, and it turns out that is the exact same image at the end, and then on resolution, the oracle says, oh, sorry, now it's not a suit, right? Something very small has changed, and it's not a suit. For this, you need reproducibility, right? You need to be able to replay time and time again the exact same input to get the exact same output. And that is determinism, right? You would hear online a lot of things on chain, especially of we've got trustless AI, or we've got verifiable AI. Many of these protocols that are doing, I'm sure, amazing work, they miss something very, very important. And that is, it is very nonsensical to say we've got verifiable AI inference, when in fact the inference itself is not deterministic, right? And if you want to get deterministic AI inference, you need to get to one objective and one objective only, and that is every time you play with the same seed, you must have bit by bit the same output. Of course, this is very complex. How can you perfectly compute every single bit in a logic gate that is going to get activated? But there are definitely ways, and I'll show you in a bit how we make it happen. But before I talk into more of the nitty-gritty of the settings, the parameters that need to be activated, let me give you a very high-level architecture of the Oracle system that we are developing. It would be most likely open source, so that everybody trusts it, open for other protocols to use, but of course, with Kash leading the user experience, that enables this permissionlessness and this trustlessness when it comes to resolution, right? So we begin on the left with the AI model. It could be open source, it could be closed source. Open source is ideal because you can better manage the parameters. You don't have to trust even that the request is going to change in the pathway, in the distribution. You don't have to trust as well the response for the provider. Let it be OpenAI, that the parameters, the temperature, all these things are what they're telling you. So obviously, closed source is not ideal. And then you execute all of that within a TEE. Today, actually, you would be surprised by the level of compute power that SGX has, but obviously you cannot execute a larger model on an SGX. You would rather prefer a TDX approach. And that TDX gives you two things: a decap attestation of the integrity of the computation and the actual output of the LLM model, right? And these two things go into a ZKVM. You recompute the entire attestation from scratch in the ZKVM. It could be risk zero. They've been doing an amazing job. It could be Success SP1. Actually, it's a super crowded space, so you can find everything right and left. And it would output a Stark, a ZK Stark, that is about, actually that's wrong, it's not 200 megabytes, it's about 200 kilobytes, 1,000 times more than a ZK Snark that could be wrapped around through an adapter, through Graph 16, and then proven on Ethereum or any layer 2 based on the EVM on-chain using the Ethereum attestation service or whatever. So this is probably the nitty-gritty that I was talking about and the single most important slide of this session, because it tells you, for once, it is quite difficult to find online these things or even in academic papers, but it tells you in detail what are the specific parameters that we need to have deterministic AI inference. And focusing here on the software in the middle, on the software section, there are several main points, but the main ones are four, which is the decoding policy, which includes the temperature, the PRNG, which is a pseudo-random number generator. I'll explain exactly how it fits into the stack and how that pseudo-random number is generated within an LLM. It's quite important to know the basics, to know how everything works, how the sample configuration works. There is the top K, the top P, all these technical terms that pretty much mean, am I choosing the top 50 tokens right after the softmax function, or am I choosing the top tokens that amount to 90% probability, right? Which may be 20, maybe 200, right? And then the PRNG is the actual algorithm that chooses the next token. So yeah, if you're not using local AI models at home or in your company, and you have to submit a request to conduct deterministic AI inference, most likely you would like to wrap and package all these parameters in a container digest, right? Which includes the GPU architecture, Blackwell, H200s, H100s, the seed, the driver, the kernel that you're using within the GPU, the decoding policy, and all these elements that I've discussed. So now let's talk about a few misconceptions of the temperature, the PRNG numbers. Many people think, well, if I put the temperature down to 0, it's going to be deterministic, the output, right? And well, the answer is it doesn't suffice for the temperature to be down to 0, and nobody wants the temperature down to 0, apart from, of course, certain commercial cases where you're extracting information from a document or things like that. But if you definitely want enough fluid intelligence to be happening in the model, you need some sort of, after the sentence of there is not a single path to get to the destination, right? To get to the solution. It is the exact same thing in LLMs. On the right, there is a circle. Let's imagine that circle amounts to the corpus of knowledge after the training of the LLM. And obviously, right in the middle, there is a gap, right? There is a gap in knowledge. It could be a time in history that it hasn't been written about. It could be a question, it could be the answer to a question that doesn't make sense or it's to something that hasn't happened yet. Anyways, there are gaps all around. So if you're asking certain questions right very close to that gap layer, right, to that gap horizon, and you have certain points, certain questions that you're asking, it is very easy for the model with the temperature down to 0 to fall into a cycle, right? So if you're predicting the next word, you're blindly going through a room, right? Just touching, if you can touch anything with your hands, right? And you're going full speed, thinking that if your hands are not touching anything, you can go even faster, right? So you might end up falling. You might end up falling through the window, right? You're going blind in this sense. So yeah, temperature definitely gets you. There's a much higher probability that you end up in a cycle, and of course there is no creativity. You develop very brittle intelligence, so to say. So yeah, about PRNG and sampling, the second most important parameters when doing deterministic AI inference is to understand that it's important to see what happens under the hood, right? At the beginning, you have the input, make America great, and then the text must provide and must guess what the next word is. As you know, every token is between 3-4 letters. It changes, but generally that's the case. It first goes through attention layer, then it goes through multi-layer perceptron, then it goes through attention again, time and time and time again, right? Until you get to the logits, you get to the nonlinear functions, softmax, top K, top P, and at that moment, when you have an array of, let's say, 200 different numbers, which represent maybe 150 words, you must choose the top 50, or those that amount to 90% likelihood, or 10% likelihood, and then from those, PRNG chooses the word again, right? And even though it was random, the way the word again was chosen, it is a pseudo-random algorithm. So were you to run the whole thing again, you would get to the word again once more, right? And that's the point of PRNG when it comes to deterministic inference. And there is we're a bit tight on time, but to resume as well, what are the biggest problems if I don't set up these parameters right, is, well, you get to a point where you get to floating point non-associativity, right? And everything about AI, mostly everything, every computation, is about matrices. It's about multiplicating different matrices together. And depending on how you sum matrices and arrays, you can get to a very different output at the very end if you atomically round up and you do that sequentially, right? As opposed to summing up everything together, right? In the case of A, B plus C, or A plus B plus C in parentheses, right? It changes completely. It happens throughout the entire life cycle of the LLM, from kernel scheduling to variable batching to KV cache memory. And KV cache memory is essential for this sort of thing, for the attention mechanism. So let's very briefly, in the last 3 minutes, talk about how we are building a whole new Oracle system when it comes to resolution, right? And even though it boils down to 4 main points, there is almost a year worth of research. And of course, I'm standing on the shoulders of giants in this case, from people like Andy Hall or people like Karpathy. They have worked on very similar methods to create a multi-agentic reasoning system. But anyways, the main 4 points is the single model echo. The fact that even if you divide the same model into tasks, to plan, to execute, to deliberate, to observe, to self-critique, as long as it feels within the same context, you're prone to way poorer results, right? So the quality will be way less. AI has different weaknesses inherent to the infrastructure as well. Choosing the next token, if you don't have any rack system, it is very difficult to know whether you're going in the right direction or not. LLMs have a very hard time knowing that they're living on 2026, knowing which model they're running. So obviously these things, you must be very careful when selecting and engineering the prompt according to these weaknesses. There is overconfidence without self-correction, again, unless they look online or they have a RAG system, and sensitivity to procedure and framing. And I saw a tweet the other day, actually, that summarizes that quite well. You can ask an LLM, who is Tom Cruise's mom, and probably would tell you Mary Lee South. But then if you ask, who is the son of Mary Lee South, it would have to look online. It doesn't have the answer, right? This is to say, do not treat the prompts as if the LLM was a database. It has a completely different infrastructure, and this is extremely important to learn how this works. And the last slides simply means, what is the performance between executing on a single model versus executing in an LLM council. An LLM council with different stages, with deliberation, and so on. And it turns out that there is a 99% accuracy once you actually add roles, personalities, persistent memory, reputation, and anonymized models. So yeah, that should be it. Feel free to ask me later at any point. DM's always open. Thank you very much.